Imagine you're at home and you're getting hungry, so you decide to grab a snack. Maybe you go to the refrigerator and you grab a can of soft drink, a glass of milk, maybe you get a glass of water from the tap. All of these things are made from a chemical engineering process. And then at the end, you go to the bathroom, you flush the toilet. The treatment of that wastewater is also a chemical engineering process. We're here at the Western Treatment Plant, which handles about half of the wastewater from Melbourne. One of the problems with handling sewage is it produces biogas, which contains a lot of methane, and methane has a global warming potential about 25 times higher than carbon dioxide. So one of the interesting innovations here is they've covered their lagoons and they can collect the biogas. Now, at the very least, you could just burn it and you'd already get a 25 times improvement in the overall pollution effect. But by burning methane, you also generate heat, and heat can be used to generate electricity, and that electricity can be fed back into the grid. It's 100% renewable, and it offsets the production of electricity via dirty brown coal. So that's just one of the really cool innovations produced by chemical engineers. In the major, you'll learn the fundamentals of chemical engineering and have the opportunity to apply that to real-world practice. For example, in our wastewater treatment prac or our fluid mechanics prac, you'll be able to replicate some of the processes that are happening around me here today.
I chose to study chemical engineering because when I was in high school, I discovered I had a really big passion for chemistry, but I couldn't imagine myself sitting in a lab and doing lab work. So with chemical engineering, you can really apply chemistry in everyday real life scenarios and see your projects come to fruition. Particularly at the University of Melbourne, the staff in the chemical engineering faculty are really knowledgeable and all very wonderful. They cover a wide range of research disciplines, so it gives me the opportunity to engage in research in whatever area I choose. Chemical engineers can work in a wide range of industries. The ones that I'm probably most interested in are food, water and pharmaceuticals, but I'm still undecided where I want to go. And this semester I'm actually undertaking an internship with a medtech startup company, so I'm getting to see a whole other side of engineering as well.
After the undergraduate degree, the majority of our students continue on to the masters to become fully accredited chemical engineers. People often think of the mining sector and petrochemical industry when they think of chemical engineering, but in reality, the majority of our graduates go into biotechnology, engineering consultancy, food and beverage, water treatment, and also emerging technologies. People often think that innovation just happens, but we need engineers to design and implement and then manage those innovations. Chemical engineering is across so many aspects of our daily lives that it's really essential to get to that sustainable future that we all want. But there's a critical skills shortage of chemical engineers. If you study with us, you can be part of that solution.